Hi, this video demonstrates methods for measuring water levels in wells using an electric tape. The electric tape method is commonly accurate to 1/100th of a foot. It is most accurate when the depth to water is less than 200 feet below the land surface. The materials needed include keys to access the well, a pipe wrench, water for testing the probe, the electric tape, a PDA for electronically recording measurements, a cloth, soap, and water for cleaning the probe, a water level measurement field form, and writing utensil. Step 1. Determine you are at the correct well from the well description and locate the documented measuring points and land surface datum from the well, photo, or diagram. If using electronic field data, pull up the file for the well and also enter the serial number of the tape used for measurement. Step 2. Open the well with a pipe wrench. Step 3. Ensure that the electric tape is working properly by dipping the probe into tap water and observing whether the indicator is functioning properly to indicate a closed circuit. Make sure that all readings are made by using the same deflection point on the indicator scale, light intensity, or sound so that measurements are consistent. Step 4. Lower the probe slowly into the well until the indicator indicates that the circuit is closed and that the water surface in the well is contacted. Place the nail of the index finger on the insulated wire at the measuring point and read the depth to water on the graduated tape. Step 5. Record the date and time of the measurement on a water level measurement field form or a digital screen input form. This is automated with electronic data entry software like Monkeys. Record this value on the row hold. If a correction is needed, record the correction amount on the row tape correction and subtract from the hold value. Record this difference in the row water level below measuring point. Step 6. Record the measuring point correction length on the MP correction row of the field form. The MP correction is positive if the MP is above the land surface or negative if it is below the land surface. Subtract the MP correction length from the true water level below measuring point value to get the depth to water below or above the land surface datum. Step 7. Pull the tape up and make a check measurement by performing the previous steps. Record the check measurement on the field form. If the check measurement differs from the original measurement by greater than 0.02 foot, continue to measure the water depth until the reason for a lack of agreement is determined or the results are found to be reliable. Complete the final measurement for GWSI portion of the field form. Step 8. Close the well with a pipe wrench, making sure the lid is securely fastened. Step 9. After completing the measurements, disinfect and rinse the part of the tape that was submerged, as described in the National Field Manual in order to reduce the possibility of contamination of other wells by the tape. Note: the electric tape should first be calibrated against a reference steel tape. The reference tape should be kept in the office and used only for calibrating other tapes. Keep in mind the following limitations of this method. Oil, ice, or other debris may interfere with a water level measurement. Corrections to the measurements are necessary if the well casing is angled, and when measuring deep water levels because of tape expansion and stretch. This approach has several advantages. The electric tape is superior to a steel tape when water is dripping into the well or condensing on the side casing walls, when a rapid series of measurements are needed, such as during an aquifer test, because measurements are obtained quickly and the tape does not need to be lifted from the well for each reading. It is also superior in wells that are being pumped, where the splashing of the water surface can have little impact on measurements, whereas the splashing can produce additional wetted marks on steel tapes that do not indicate the depth to water. This method, however, has several disadvantages. The electric tape is more difficult to keep calibrated than a steel tape. The electric connections can fail and require maintenance. The electric tape requires battery power. The cable jacket is subject to wear and tear, which can sever the electric circuit. The electric tape may not give accurate readings if the water level in the well has a very low specific conductance.